Okay. So as I say, for your tutorial question, we have done until questions 11, then we should continue 12. I haven't discussed any for 12, right, students? Just to confirm.
No, yeah, miss.
Not yet, huh? Okay, thank you. Okay, now let's look at questions 12. You are required to use a de Moivre's theorem. Simplified in the A plus BJ form. That means you need to use de Moivre's theorem here because you can see there's a power of 4, power of 6. Then it will be easier for us to actually using de Moivre's theorem to evaluate it. Okay. However, they require, when we use de Moivre's theorem, right? Remember our complex numbers in the polar form. Okay. When we applied the de Moivre's theorem must be in the polar form. Okay. So for your recap, okay, then however, okay, the questions here, they required the final answer in Cartesian form. Okay, so you need to take note about that. Okay. Okay, now let's start with part A. Okay, part A, the questions is in the polar form. Okay, this one also considered as a polar form. Okay, because it's in R, then cos theta plus j sine theta. So this is also a polar form. Then with the power of 6, okay, so from part A here, okay, so for the part A here, okay, so what you can do is you identify which one is a R. So this one is a R, right? Okay, and then of course this one is your theta. Okay, then from here we just can rewrite it as a R, which is 2 angle 20 degree. Okay, in the it's also in polar form, but in the abbreviation form. Okay, so then we have a power of 6. Okay, power of 6. Okay, so now we can directly apply the de Moivre's theorem. So which 2 power of 6, then the angle will be 20 degree times 6. Okay, then let's get the final answer. Okay, 2 power of 6 will be 64. Then the angle is 120 degree. Okay, so this is the answer. So this one is a very simple one, right? Okay, however, you need to convert it into A plus BJ form. Okay, so A plus BJ form. So now your R is 64. Then your theta is actually 120. Right? Okay, so what you need to do, remember, we can write it as a R cos theta plus R sine theta. So I can write it as 64 cos 120 plus 64 sine 120 degree. Okay, then you just calculate. Okay, let's calculate the value. Oh, okay, ilalang, okay, noted. Good, okay. Okay, so let's calculate the value. Okay, you can calculate in the decimal. So 64 cos 120. Okay, so what do you get? Okay, so when come to this form, right, you don't need to, you just directly use your calculator and calculate. Okay, so can I have Benny, what is the answer? Can you give me the answer in chat box?
Hold on, miss, I'm getting it.
Okay, later you put your answer in the chat box. Okay.
Miss, there's supposed to be a J at the sign, is it?
Ah, yes, correct. I miss out the J. So remember to put your the calculator, right? The mode is in degree, not radian. Okay, be careful when come to this topic. Okay, make sure you take note when every time when you calculate for the angle, okay, or the trigo. So is it in the radian or is it in the degree? Okay, so Benny, have you get the answer ready? So you just need to follow what is given here and put in your calculator 64 times cos 120. What do you get? Okay. So yeah, okay, I can see a few answers from Samuel, from Sutej, from Benny, from Iralam. Yeah, all the same. Okay, yes, correct. Negative 32, okay, plus 55.43 if you put in the two decimal places. Yep, everybody get the correct answer. Okay, thank you. So now let's proceed to the second one. Okay, second one, we have a square root of 2 minus j square root of 2 power of 4. Okay, so this one is in the Cartesian form, but unfortunately we need to evaluate the power of 4. Then by using the De Moivre's theorem, then we need to change it back to the polar form. Okay, so when we look at here, okay, so can you see the x is actually square root of 2, and then for the y is negative square root of 2. Okay, so we need to find the r first. Okay, so the r is the square of the x plus square of the y. So square root of 2 square plus negative square root of 2 square. So that means you have 2 plus 2 square root of 4. Square root of 4, which is equals to 2. Okay, then next is the arctangent of y over x, right? So remember I always put the values without the sign. Okay, so I get arctangent of 1. So arctangent of 1 is actually equals to 45 degrees. So this is a basic angle. Okay, now, may I know what is the quadrant? Can I have someone to tell me? Okay, hold on. Okay, Kaifeng, what is the quadrant for the x positive, y negative? Which quadrant we have? Which quadrant? Kaifeng? X positive, y negative. Kaifeng, you are here, right? Kaifeng? Kaifeng? No response. Okay. Ziyi, Which quadrant?
Second quadrant.
Second quadrant, is it x positive, y negative?
Yeah, x positive, y negative.
Okay, so if you look at coordinate system, where is x positive, y negative? You check again, Ziyi. So let's say this is x, this is y. X positive, y negative, where is it?
Oh, fourth quadrant.
Yes, correct. Okay, be careful. So should be fourth quadrant. Okay, x positive, y negative. Okay, should be fourth quadrant. So 45 degree is here. So you may have a negative 45 degree. So that means theta is equal to negative 45 degree. So remember, third and fourth quadrant, we can express it as a negative angle. So negative 45 degree. Okay, that means now, okay, I can write it as R, which is 2, angle negative 45 degree, then power of 4. So it will be equals to, okay, how I calculate this one. Okay, so can I have another student? Okay, Saad, can you tell me how I applied the De Moivre's theorems to calculate the power of 4? What should I do with the 2? Saad, what should I do with number 2? Saad, are you here? Saad? Okay. So no response. Okay. Can I have Wei Huan? How to evaluate the power of 4? What happened to number 2? What should I do with number 2, Wei Huan?
16.
16. That means 2 power of 4. Okay, so how about negative 45 degree? What should I do?
Negative 180.
Negative 180. How you get negative 180?
Minus 45 times 4.
Yes, correct. Okay, negative 45 degree times 4. So which is 16 angle negative 180 degree. Okay, thank you. Okay, so next, but you are required to have the final answer in the Cartesian form, right? Okay, so that means this is the R, so this is the theta. Okay, so let's calculate the answer. Okay, so that means R cos theta, that means equals to 16 cos negative 180 degree plus 16 sine negative 180 degree J. Okay, let's calculate the answer. Okay, so can I have Harold? May I know your answer?
Negative 16.
Okay, thank you. Only negative 16, no others. Yep. Okay, so this is the answer. Thank you. Okay, so next. Okay, so next is question C. Okay, hold on. Saad say he has a connection problem. Let's try to connect back. Okay. Okay, let's continue. Okay, then we continue with question C. Okay, so C, we repeat the same thing. Okay, write it in the polar form. Okay, write this in the polar form. Okay. So that means the x is a square root of 3 and the y is positive 1. Okay, so let's calculate the r. Square for the square root of 3 plus 1 square. So you have square root of 10. Oh, sorry. 3 plus 1. Square root of 4. So which is equals to 2. Then for arctangent, okay, which is 1 divided by square root of 3. Okay, so you have 30 degree. Okay, so may I know which? Okay, yeah, Saad noted. Okay, so now is arctangent of 1 over square root of 3 for which you get 30 degree. Okay, so now how about the which quadrant? Ilalam, which quadrant? For C? X positive, Y positive, which quadrant?
First, miss, first.
First, yes, very good. First quadrant. So our theta is same as 30 degree. Okay, so no change. Okay, same as a basic angle because it's happened in the first quadrant. Okay, so next we rewrite our answer as a 2 angle 30 degree. Okay, so with a power of 7, so which is 2 power of 7, 30 degree times 7. So let's calculate for the answer. 128, then angle 210 degree. Okay, so next we would like to write it in the Cartesian form. So 128 cos 210 degree plus 128 sine 210 degree J. Okay, so let's calculate for the answer. Can I have another student to give me the answer? Okay, so Cryptacon, calculate the answer for me.
The first one is negative 113.14.
Negative 113. Point. Is it correct? Negative 113?
Oh, wait, my calculator is in radian.
Mm-hmm.
Negative 110.85.
Okay, then the imaginary part.
Negative 64J.
Okay, thank you. Okay, correct. Okay, so this is the answer. Okay. Okay, so we have done B and C. So the last is a D. Oh, D, there's a lot of calculation. Okay, so let me start D in another page. Okay, so this is part D, and we have 3 complex numbers. Each one with the power of 9, power of 4, power of 3. In order to use the de Moivre's theorem, we need to convert all of them to the polar form. Okay, so let's start with the first one. Okay, so the first one we have 1 plus square root of 3. Okay, so that means the x is a 1, square root of 3 is the y. Okay, so let's do it now. Okay, then that means the r is equals to square root of 1 square plus square root of 3 square. So we have square root of 4, which is 2. Okay, then arctangent of square root of 3 over 1, so which is arctangent of square root of 3. Okay. So which is 60 degree. Okay. So since this x and y are both positive, so it's in first quadrant, then our theta is equals to 60 degree because of first quadrant. Okay, then so for first quadrant, so yeah, let's proceed. Then it will be equals to 2, then angle 60 degree. Okay, we get this done for the first one. Then the next one is minus 1 minus j. Okay, minus 1 minus j. So let's convert this to the polar form. So let's find the r. So x and y both are -1, -1 square plus -1 square. So 1 square, 1 plus 1 square root of 2. Okay, then for the arctangent, so it's a 1 over 1. Okay, remember I don't take the side. So 1 over 1, you get arctangent of 1, which is 45 degree. Okay, but what is the theta for this one? Because this is not in the first quadrant. Okay, so we have x and y are both negative. So may I know what is the quadrant? Junho, which quadrant? Junho, which quadrant? Both x and y are negative.
Third quadrant.
Third quadrant, yes. Okay, third quadrant. Okay, both x and negative are both x and y are negative. Okay, so third quadrant then will be here, the 45 degree, right? So when come to third quadrant, remember we will put it as a negative angle. So we measures from here, right? Okay, then come to here will be we take 180 minus 45. Then which is with negative angle, -135 degree. Okay, so we apply the principal value. So we have square root of 2 angle -135 degree. Okay, then next one we have 2 plus 3j. Okay, 2 plus 3j. So again, we calculate for the r. Okay, so which is 2 square plus 3 square, square root of 13. Then arctangent of 3 over 2, which is 56.31 degree. And since both x and y are positive, so in the first quadrant, so this is theta. So square root of 13, angle 56.31. Okay, so we have all the value, all the complex numbers in the polar form. So let's substitute. Okay, so let's substitute into the equation. Okay, so now, okay, so okay, 1 plus square root of 3, okay, 2 angle 60 degree, power of 9. Then for the one at the bottom, square root of 2 angle -135, power of 4 minus what we have just now, square root of 13 angle 56.31, power of 3. Okay, so now let's evaluate. Okay, so for the first angle, you for the one at the top, you have 2 power of 9. So 2 power of 9, which is 512, and then 60 degree times 9, 540 degree. Then square root of 2 power of 4, which is 4. Okay, then negative 135 times 4, which is negative 540. Then next one, square root of 13 power of 3. 46.87. E 168.93. 168.93. Okay, wait, hold on. Square root. Let me check again. 87. Okay. Now, correct. Okay. So next, let's simplify. Okay, the division part. Okay. So how should I simplify the division part? Okay. Can I ask the students here? Manheng, how do I simplify the division part? What should I do with the 512 and number 4? Manheng?
Easy divide.
Yes, okay. So 512 divided by 4, we get 128. Okay, how about the angle? What should I do? Manheng? How about the angle? What should I do?
Just minus.
Minus, yes. So 540 minus negative 540 become plus. So 540 plus 540, so it's 1080. Okay, so this is the one with the angle, okay? And the other part is a 46.87, angle 168.93 degree, okay? So now you deal with the subtraction, right? Okay, already simplified the division. So now we deal with the subtraction. So remember, when come to the subtraction, we can't simplify using the polar form. We must convert it into the Cartesian form. Okay, so now each one of them you need to convert it into Cartesian form. So that means for the first one, 128 cos 1080 degree plus 128 sine 1080 degree J. Okay, then minus with the second one, same things, 46.87. Okay, cos 168.93 plus 46.87 sine 168.93 degree J. Okay, so let's get your answer in the Cartesian form. Okay. Okay, so Samuel, what do you get for the first one? And Sutej, what do you get for the second one? Okay, so for the first part, Samuel get 128. Yes, correct. Okay, then how about the second part? Sutej.
Give me a second, Miss. I'm typing.
Okay, can. Okay, so Sutesh get negative 46 plus 8.999. Yeah, okay, plus okay, so if you correct to 3 decimal places will be 8.999, okay? So if you correct to 2 decimal places, then you will get exactly 9, okay? So here I actually correct to 2 decimal places, so I get the 9J, okay? So yeah, okay? So Sutesh, okay, it's okay, okay? So either if you remain 3 decimal places will be 0.999. So 2 decimal places, then after rounded up will be 9. Okay, then simplify it. So 128 plus 46, you get 174, then minus 9J. Okay, so 174 minus 9J, yeah? Okay, done. So final answer in the Cartesian form. Okay, so we have done. Okay, so question 12 settled. So any questions? Is that clear so far?
Yeah, clear, miss.
Okay, clear. Huh? Okay,
Excuse me,
so
miss.
yes.
One question. Miss, when I change my calculator to radian and when I keep it on degree?
Sorry, when you need to keep it as a degree, is it?
Yeah, and when should I change it to radian?
Okay, can you see all this with the symbol of the degree? So definitely you need to calculate by using degree. Okay?
Okay.
So normally we will involve radian when come to the complex numbers that is in the exponential form. Okay, so remember if our complex number in the exponential form, so for the exponential form, the theta here must be in, this theta must be in radian. Okay, so for example, when you want to convert it into a Cartesian form, so when you rewrite into this, right, so the angle is pi over 3 radian, then when you do the calculation, you can actually remain using the radian, but your calculator, you need to change to radian in order to do this calculation. Else you need to convert to 60 degree, which I don't think you should do that. You can just change the mode of your calculator to radian, then you get the answer. I'm not sure whether I answer your question.
Okay, miss. Okay, thank you.
Okay. Okay, any other question? Okay, so say clear. Okay. Okay, now, so already done the discussion. Then the next part, we will move on to the, okay. So next we will move on to the some application. Okay. So last week, remember I posted some of the terms regarding the impedance, resistance, reactance, and so on. Okay. So I'm not sure whether you have gone through it. Okay. So let's say I repost it here. Okay, so actually I have, okay, so in case you may want to, if you are not so sure about that, okay. How come this color? Okay. Okay, I have another one as well. So just for you, just put it in the chat box. You can have a quick run through of the terms because I'm going to go through it later. Okay. Okay. So in case because I'm not sure, okay, how much you know about this. So maybe you're already familiar with these terms. You may not need it, okay. But if you want to have a recap on what is the meaning, you can read through this, okay. So now back to the slide. Okay, so we haven't go through any questions here, right? Okay, so now let's look at the first problem, okay, for the, okay, maybe I will enlarge it. Okay, so next, the impedance is actually, for the problem 1 given here, okay, determine the resistance and series inductance or capacitance for each of the following impedances, assuming a frequency of 50 Hertz. Okay, so when you look at here, all the complex numbers given here, they are impedance. Okay, they are impedance. So for impedance is a combination of the resistance and also the reactance. Okay, resistance and also the reactance. So we can express them as a complex numbers. Okay, as a complex number. And please take note, when we express them as a complex numbers, then the real part is actually referred to the resistance, and the imaginary part is referring to the reactance. It represents the reactance. Okay, so please take note about that. Okay, okay, it's a combination of resistance and reactance. Real part is resistance, imaginary part is represent reactance. Okay, so now when the imaginary part is positive, okay, so come to the impedance. When the imaginary part is positive, okay, so when it is positive, that means the reactance is inductive. And if the imaginary part is negative, then the reactance is capacitive. Okay, so later you will see how we do the calculation. Okay, so for you to take note about this. Okay, now let's start with the first one. First one, we have an impedance of 4 plus J7. So as I say, resistance is referring to the real part. So the resistance is actually equals to 4, and the reactance is actually 7. Okay, so as I mentioned just now. Okay, now so come to the imaginary part. Can you see the imaginary part is actually with the plus, positive, right? So when the imaginary part is a positive, then the reactance is actually inductive. So as I mentioned just now, okay, when the imaginary part is positive, then the reactance is inductive. Okay, so now how we actually calculate the inductance? So because the question asks you to determine the resistance and also the inductance or capacitance. Okay, so since the reactance is inductive, then we will find the inductance. Okay, find the inductance. So this one is using the formula. Okay, so just now the reactance is actually identified it as a 7. Okay, identified as a 7. So the reactance is actually equals to 2 pi FL. Okay, so the L, which is referring to the inductance. Okay, so from this formula, okay, we rearrange to get the L. So L will be XL over 2 pi F. So the XL here, which is referring to the reactance, So I substitute as values of the reactance. And then the F, which is the frequency, which is already given by the question, 50. Okay, so 2 pi times 50. Okay, then do the calculation. So when you calculate, you get 0.0223. Okay, 0.0223. Yeah? Okay, so this is the answer. Okay, this is the answer. Okay, so I think in the chat box just now, you can also see what is the unit that is given for the inductance, right? Okay, so I put in the chat box. So for inductance, the unit is calculated as a henries. Okay, the unit henries. Okay, so they're using capital H as a notation here. Okay, henries. And then can you see actually this is a correct answer already. This one is a correct answer. But because normally when we calculate this value, right, it is quite small. Okay, so the answers here, they put it in M. Okay, so M, which is referring to milli. Okay, so here is referring to milli. Okay, so which is 22.3. Huh? Okay, 22.3. Okay, when we have a milli. Of course, this one is also correct. Okay, you can just remain your answer as 0.0223 henries. Okay, okay, so next one, more examples. Okay, B and C. B is another complex numbers. So come to part B, right? Okay. Okay, come to part B, there's another impedance which is given as J20. There's no real part is a 0. So that means the resistance will be a 0. Okay, because the real part is a 0, then the reactance is 20 because the imaginary part is 20. Okay, now, since the imaginary part is negative, so the reactance is capacitive, as I mentioned just now. Okay, so with the reactance of 20, then we have a formulas of XC, okay, equals to 1 over 2 pi F capital C. So the capital C here, which is referring to capacitance. Okay, capacitance. So you ask to find inductance or capacitance, right? So since there's a negative for the imaginary part, so here you are calculating the capacitance. So for capacitance, when you rearrange the formula from here, okay, so your answer will be C equals to 1 over 2 pi F XC, okay? 1 over 2 pi F XC. So the F is a frequency, substitute as a 50 given by the question. And then the XC is the reactance, okay? The capacitive reactance. Then you just substitute and you calculate. So the unit is in farad, okay? So when you calculate, you get quite a very small numbers, okay? So hold on, so let me calculate. So what do you get here? The original answer is actually 0.00015992. Yes, okay. So the answers you get is 0.00015992. So here they just put it as a microfarad, okay. So for this one, this is your answer, okay, original value, okay. So here they just put it as a microfarad, okay. So you can check it online about the milli, about the micro, right, okay. So next, okay, so done for this one. Okay, the next one, the third complex numbers is actually given as a polar form, 15 angle negative 60. Okay, so in order to know which one is a real part and the imaginary part, you have to write it in the Cartesian form. Okay, so we write this as a Cartesian form, so we calculate as 15 cos negative 60 plus j sine negative 60. So we have 7.5 minus j12.99. Okay, so this is in our Cartesian form. Then next we identify the reactance. So as I say, the real part is a resistance, sorry. Then the imaginary part is a reactance. Okay, so since this is negative, so when it is negative, then we have capacitive reactance. Okay, because the imaginary part is negative. So that's why it's capacitive reactance. So the reactance is 12.99. Again, we use this formula to find the capacitance. So the capacitance, which is referring to the C. Okay, which is referring to the C, the capacitance. So we'll rearrange it to calculate the capacitance. So this is our formula. So let's substitute. Okay. So you can substitute the formula as 1 over 2 pi. The F is a 50 frequency. The XC is 12.99. Okay. Then when you calculate this one, you get a very small number. So you get 0.000245. Okay, so 0.000245 farad. So this is the original answer. Here they put the micro, so you have 245. Okay, okay, so this is how we do the calculation. Okay. Okay, so if you don't put it in micro, it's fine. You can just put it as original numbers. Okay, so you can try to recall back. Okay, so milli, micro, nano, pico. Okay, so you can find all these. Okay, just now we have a milli, 10 power negative 3. So we have a micro, which is 10 power negative 6. Okay, so for your info, okay, so this is applied in the calculation just now. Okay, for your information. Okay, okay, so next one. This is our last example already. Okay, after this one, I give you a break. Then we will continue with the rest of the tutorial questions. Okay, so we have other tutorial questions which is related to the application part. Okay, so second problem. Okay, second problem is about an alternating voltage of 240 watts. So 50 Hz is connected across an impedance of 60 minus J 100. So this is an impedance given, and you are asked to find the resistance, capacitance, the magnitude of the impedance and its phase angle, and also the current flowing. Okay, so these are the 4 requirements of the question. So now let's look at the first one. Okay, so first one, you require to find resistance. So remember, you just need to identify the real part, so which is a resistance of 60. Okay, 60 ohm. Okay, next one, you are required to find the capacitance, right? This one done. Second one, capacitance. So since this is a imaginary part is negative, so when this is negative, then the reactance is capacitive reactance. Okay, then you can find the capacitance by using this formula. So the same formula we go through just now. Okay, so let's substitute the frequency as a 50 and the reactance here is 100, so substitute as 100, then you do the calculation. So this one, they already put the micro, huh? Okay, so if you calculate this answer, this one should be a very small number, 0.000033183, huh? Okay. Okay, so this is the original answer. So with the micro, then you can write it as a 81.83 micro. Okay, so as I say just now, micro is actually 10 power minus 6. So that means when you shift the binary point 6 places to the left, you can get back to the original number. Okay, so capacitance done. So next one, you ask to find the magnitude of the impedance and the phase angle. So to find the magnitude of the impedance, you will find the Z, okay, magnitude. So remember the magnitude, we are taking the A square plus B square, okay? The square of the imaginary part and the square of the real part, okay? So you get the magnitude of 116.6, okay? 60 square and negative 100 square, okay, from the complex number. Okay, then for the phase angle, that means it's referring to the argument, okay, argument. So the argument means the arctangent, okay? Okay, as I say, I normally don't put the sign. So if I exclude the sign, it will be 100 over 60. So I will get 59.04 degree. Okay, then for 60 minus J100, right? So the X is positive, the Y is negative. X positive, Y negative, that means it's in the second quadrant. Okay, wait. Oh, sorry, X positive, Y negative, fourth quadrant. Okay, fourth quadrant. So the fourth quadrant, okay, so that means negative 59.04, okay, so that's why here is negative 59.04, fourth quadrant. Okay, then so this is the answer. Okay, then next is the current flowing. Okay, so for the current flowing is equals to V over Z, okay, the voltage divided by the impedance, Z. Okay, so for the voltage is given as 240 watts. Okay, so here we can using polar form to solve it because we deal with the division, right? Okay, we deal with the division. For polar form, we have rules to actually solve, evaluate the division. So at the top for the voltage, we put 240 with the angle of 0. Okay, then for the bottom, which is our Z, so Z, the impedance, the magnitude, we found it as a 116.6, which is the R, and the theta negative 59.04 at the bottom. So then remember using the rules to actually evaluate this one, 240 divided by 116.6. Then for the angle, you have to take 0 degree minus negative 59.04. Okay, so negative, negative, plus, right? So 59.04. Then 240 divided by 116.6, you get 2.058. Then this is the angle, current flowing in ampere. Okay, so this is the answer. Okay, and we have done. Okay. Okay, so we go through a lot of the things for these complex numbers. Okay. So the last part is the de Moivre's theorem. Then we involve some applications of the complex numbers. Okay. So which is involved the impedance. Okay. Then we have done. Okay, and we have two more questions for the complex numbers. Okay, so I give you a 10 minutes break, then we will come back for these two questions. So after these two questions, if we have time, then we will go through on the, we will start the new topics, okay, if we have time.
Miss, can go back to the last
Yes.
page. Can go back to
Sorry?
the current can go back to the previous question. How about the current?
Sorry, the current question? Oh,
The one in the slides.
oh, okay.
So Miss, for the magnitude, why you have to find the angle?
Okay, so because the questions here, they require for phase angle.
Okay.
Okay.
But they can also just say find the vector, is it, of the impedance?
Okay, so they want the magnitude and also the phase angle. So that's why the magnitude, remember, at the beginning, we already defined the magnitude as a square root of a square plus b square. Okay, and the angles here, which is referring to the argument.
Okay. Can you pause at this page?
Okay.
Yeah. I just want to digest this.
Okay. Okay, it's okay. I will proceed for the 10 minutes break. Okay. Then I will leave the page as this one. Okay. So anything and actually I have a videos lah, okay, about the phase angle. So let me post it here. So maybe you can try to, because to be frank, our content, we don't actually cover phase angle and so on, okay? But on the applications, they involve all these things, okay? So then I found a video, so I put it here. Then maybe you all can have a look later, okay? So I put it in the chat box, okay? The video is actually 14 minutes, but I think you just need to watch for the first 5 minutes. The rest is up to you, okay? But about the phase angles, you can focus on the first 5 minutes, okay? Okay, so I will proceed to give you the 10 minutes break, okay? Then I will put the timer, then we continue after 10 minutes. Then later I will leave the page of the last question that we stopped, okay? Okay, 10 minutes break. Okay, students, let's continue. So let me take the attendance first. All right. Okay, so today is a T4. Mm, 2 hours. Okay, mark your attendance. One more student. Samuel. Samuel. Just now Samuel is here, right? Samuel haven't come back. Okay, so let us continue. Okay, so already done the slide. So the next is the last two questions for our tutorial. Okay, let's look at questions 13. Okay, for questions 13, right? Okay, there are two impedances, Z1 and also Z2 are connected in parallel. So the total impedance ZT is given by this, okay? So just now we have two, right? So now ZT is referring to the total. So total is combined as a Z1, Z2 divided by Z1 plus Z2. So determine the magnitude of the current in polar form. Given the voltage supply is 120 volt. Okay, so you need to find the magnitude of the current in polar form. Okay, so please take note, if you wish to find the magnitude of the current, right? Okay, so in polar form. So that means later you need to write the current in polar form. Okay, so remember just now the for the last question is actually current equals to V over Z, right? V over Z. So where the V is a volt, right? Voltage supply, so 120, and the Z is actually the impedance. Okay, so this one is the impedance. So for the impedance, okay, we still need to do the calculation because just now we have two impedances and we need the total impedance here, okay? So total impedance is given as this one. So you need to calculate this one first before we can proceed to calculate this one. Okay, now, so let's find the ZT, okay, which is equal to Z1, Z2 product, okay, Z1 multiplies Z2 divided by Z1 plus Z2, okay? So next, okay, Z1 product Z2. So Z1 is actually 5 plus 10J. Then Z2 is 10 plus 5J. Okay, so divided by 5 plus 10J plus Z2, which is 10 plus 5J. Okay, so now you need to evaluate this one. Okay, so guys, can you try this out yourself? Try this out right now. Okay, so because we have learned all these things before, how we multiply, how we do the product for the complex numbers in the Cartesian form, and how we do the addition. Okay, so let's do it now. Okay, Samuel is coming back. Okay, continue with the question. Okay, so Cheng Hao given as the answers you given is the final answer, is it? Not the final answer. Kind of quite a big difference. Okay, so Cheng Hao, why not you give me the multiplication part, the one at the top.
Okay. 50 plus 25J plus 100J plus 50J square.
Okay, so plus 50J square. Okay, so the one at the bottom will be easy. It's an addition. So 5 plus 10, which is 15. 10J plus 5J, which is 15J. Okay, so the one at the top, this one will be negative 50, right? This part will be negative 50, so plus 50 will be 0. So we have 125J at the top. So the bottom is 15 plus 15J. Okay, so this is after we simplified. Okay, then okay, so we deal with the division. So now our question is, what should I do for the next? Can I have Saad? Can you tell me what should I multiply, Saad? Saad, are you here? What should I multiply? What should I multiply? So now we deal with the division. What should I multiply? Remember the conjugate? Yes, 15 minus 15J. Correct. Okay. So that means the bottom will be 15 square plus 15 square. Right? The bottom is 15 square plus 15 square. So the top will be, okay, 125J times 15. So which is 1875J. Then 125 times 50. Okay, so then will be negative 1875J square. Okay, so let's simplify it. So the bottom is 450. So the top you have j squared, which is minus 1, so become plus. Okay, become plus. So you have 1875 plus 1875j. Okay, so after simplify, okay, then hold on, the question. Okay, so we need to write this into polar form because we need to go further for the calculation of the I. Okay, so we need to write this as a polar form. So 1875 divided by 450, which is 4.17 plus 4.17 J. Okay, so or I can put it in the fraction first, so to reduce my rounding error. Okay, so 1875 over 450, so I have 25 over 6 plus 25 over 6j. Okay, so next we calculate the polar form. So R is equals to 25 over 6 square plus 25 over 6 square. Okay, so which is square root of 625 over 18. Okay, 625 over 18, which is 5.89. Okay, 5.89. Okay, then next one is arctangent. Okay, so both also positive value. So 25 over 6 divided by 25 over 6 is actually arctangent of 1. So which is 45 degree. Okay, so the theta, the argument is 45 degree. So when we rewrite, is a 5.89 angle 45 degree. Okay, first quadrant. Okay, next one. So next one, you need to determine the current in the polar form. Okay, so okay, which is I equals to V over Z. Okay, so the V, which is a voltage given as a 120. Okay, so let's put 120 in the polar form, and then the Z you already obtained as this 5.89 angle 45 degree. Okay, so now let's calculate. Okay, so 120 divided by 5.89, so you get 20.37. Then for the angle, so 0 minus 45, so negative 45 degree. Okay, so this is the answer. Okay, because they asked the answer in polar form. Okay. Okay, so is that okay, students?
Yeah, okay, miss.
Okay. Okay, then next, the last question. Last question is 14. Okay, so last question, you are given E390R112, L 0.06, C is 0.004, P is 250. Calculate the polar form of this. Okay, so you are asked to calculate the polar form of this. So guys, can you try this now? Okay, so for the formula that given, you just need to substitute. Okay, substitute, and please take note here is in J. Okay, in J, there's a real part and the imaginary part. Let's try to do it now. So I give you 5 minutes. So again, you are going to apply what you have learned, how to deal with the division, multiplication of the complex numbers. Okay. So you do substitution first, okay, based on the value given. Five minutes, let's do it now. Okay. Okay, so what is the first step to solve this question? So for the values given, you just substitute into the formula, right? So according to the E is actually 390. Then for the rest, the R is actually 12 plus, okay, there's a bracket. Okay, there's a bracket. So P is 250 times L, which is 0.06 minus 1 over PC, which is 250 times 0.004. Then close the bracket. Then J. Okay. So may I know what do you get after you simplify? So at the top is 390, right? What do you get for the bottom? After simplify, what do you get for the bottom?
12 plus 14J.
12 plus 14J. Yes, correct. Okay, thank you. 12 plus 14J. Okay, so the next is you need to deal with this division, right? Okay, then you need to multiply it with the conjugate. Okay, so what is the complex conjugate I should multiply? Excel? What should I multiply, Excel?
12 minus 14J.
Yes, thank you. 12 minus 14J. Okay, so next we need to multiply them. Okay, so for the bottom, okay, as usual, 12 square plus 14 square. Then for the top, 390 times 12. So we get 4680 minus 390 times 14, 5460J. Okay. Okay, so next we try to simplify further. Okay, so the one at the bottom, we get 340. Okay, now let's yeah, your final answer must in the polar form. Okay, so 4680 divided by 340. So you have okay. Okay. So when I write in the fraction, this is what I get. Okay, then you need to find the polar form. Okay, so as usual, find the R. Okay, then for the arctangent, okay, so what do you get for the R? Okay, can I have students to give me the R? Who is not being called? Okay. I think all students I call already. Okay, except some never replied. Ziyi, what is the R? Ziyi?
Wait, yeah, miss, give me a second.
Samuel, I don't think your angle is possible.
No, Miss, I wrote wrongly. I'm adjusting it now.
21.15.
21.15, yes, correct, 21.15. Okay, thank you. So next one is a arc tangent. So arc tangent, we have okay. So when you calculate for the arc tangent, what do you get? Kai Feng? What do you get when you calculate the arc tangent? We ignore the sign first. Kai Feng? Okay, so Kai Feng put 21.15 angle negative 49.4. Okay, when you calculate the basic angle, you get 49.4. Okay, 49.4. But this one is x positive, y negative. So it's in the fourth quadrant. Okay, fourth quadrant. So for fourth quadrant, so our theta will be negative 49.4. Okay, so that means our answer will be 21.15 angle negative 49.4. Okay, in the polar form. Yes, is correct. Okay. Okay, so we have done. So for these topics, okay, is there any question? Is that clear so far?
Yeah, clear, Miss.
Clear. Okay.
Miss, just now is I answer or not Kai Feng.
Oh, your answer.
I accidentally helped Kai Feng to answer.
Okay. Okay, thanks. I thought it's Kai Feng. Because I see the surname T, then I didn't, just very fast, so I thought it's Kai Feng. But Kai Feng is not responding to me today, so I'm not sure whether he's here. Okay. Okay, so done. Okay, we settle complex number done. So we are supposed to start the new topics. Vectors is our last topics. But vector, we are not going to cover so many things, okay, as compared with complex numbers, because complex numbers, we really deal with a lot of the calculation, but this is not for the complex, for the vector, okay? But complex numbers, students never do it in previous study. But when come to vector, so I believe vector, right? Most of you should have learned vector in the physics, right? Okay. So that means you should have some basic knowledge about the vector. Okay. MS also have, I couldn't remember. Okay, MS have, but I know physics, yes. Right, MS have, okay, so that means you have gone through this vector. Okay. Okay, so let us have some, okay, so I try to clean the slide. Okay, previously I write a lot. Okay, so let's have some introduction about the vector. Okay. Okay, so come to vector, right? Okay, vector may be represented, hold on. Okay, so for vectors, we will cover these four: addition of the vectors, resolutions of vectors, application of vectors, vector in three-dimensional, dot product, and cross product. So at the end, again, we have some applications which is involved dot product and cross product. Okay, about the vector. So the learning outcomes. At the end of the topics, you should be able to solve the engineering problems, the relevant engineering problems. And we start with the definition of the vector. Okay, so vector we represented by a straight line. Okay, and the length of the vector, the length of the line, okay, represented by vector represented by straight line, and the length of the line being directly proportionate to the magnitude of the quantity, and the direction of the line being in the same direction as the line of action of the quantity. Okay, so when come to vector, there are two things. Okay, the magnitude and also the direction. These are the two main things about the vector, the magnitude and the direction. So we always represent the vector as a line, like what you can see right here. Okay, so the magnitude, which is referring to the length, okay, the length of the line here, okay, the length of the line here, which is proportionate to the magnitude, okay, represent the quantity. And then the direction, okay, so which is, can you see when come to different vector with the different direction? So it's showing the different angle. So we can have a vector which is with the different angle. Okay, that is the direction of the vector. Okay, so the arrow is used to denote the sense or direction of the vector. That is for horizontal vector, say whether it acts from left to right or vice versa. So for horizontal vector, so that means whether the arrow is pointing to the left or is pointing to the right. So this is horizontal vector. Okay, the arrow showing the direction. Okay, so the arrow is position at the end of the vector, and this position is called the nose of the vector. So can you see the arrow is at the end of the vector? Okay, so and we call it as nose of the vector. Okay, so now there's a sample vector given here, which is in the figure given at the bottom. Okay, so for example, this is representing velocity. Okay, so the velocity of 20 meters per second at the angle of 45 degrees to the horizontal. Okay, so can you see how they measure this 45 degrees? They say 45 degrees to the horizontal, because the horizontal, this is a horizontal line, right? So this is a 45 degrees to the horizontal. Okay, and may depicted by OA equals to 20 meter per meter per second at 45 degrees to the horizontal. Okay, so we can also describe it as this. So OA. Okay, so the whole thing is a vector. So it's represented as a velocity. This is a velocity. Okay, so we can also show the direction. Okay, because here is the origin, right? Okay, then come to here, let's say it's a A. So we can also define the whole line as a OA equals to 20 meters per second. Okay, at 45 degrees to the horizontal, which is describe the direction. Okay. Okay, for your information, let's say we have a vector, okay, with this direction. So let's say this is 20. Let's say this is 10. Okay. Let's say the velocity of 10 meters per second. Okay. Then say I have another one. Also the same direction. And let's say this length is double of the first. This length is double of the first. Okay. So then this one with the magnitude of 20 meters per second. Okay, with the velocity of 20 meters per second. So when the length is double of the earlier one, so that means the magnitude will be the double of the earlier one as well. Okay, So same things is if I have another vector, let's say this one just half of the length, okay, for the first one, okay, half of the length with the same angle. So that means this one is representing 5 meters per second, okay. So please take note about this, okay. So it's the value is actually proportional to the length, okay. So these are the notation for the vector. There are many, okay, there are many. So we can using the ballpoint, okay, bullet, okay, to represent the vector. So for example, just now we have a vector which is start from, this is a direction. Let's say from point O to point A, okay, we can just represent the vector as a OA. Then just bullet, okay? And the other way of writing the vectors, which is we put an arrow. So this is quite a common one, right? Put an arrow on the top, okay? To denote the vector. And then and the direction as well. So because the direction is from A to B, okay? So we understand that there is a vector which is start from A then to B. So we understand there's a vectors which is like this, okay, from the direction, okay, because they really indicate the direction. So where the A is a starting point and B is the end point, okay. And there's another way of present the vector, which is a line over the top of the letters, okay, as given here, okay. And the other one is underline, okay. So let's say we're using A to represent the vector. So we can just put a line below the A to represent the vector, okay. And the other one, which is writing as a xi plus yj. So this one should be quite a common one, okay. So I think for what we have studied, I think the first one also quite common. Okay, first one in those reference books, you can see quite common. And the number 5 is also quite common. Okay, these 3 are quite common. So where I and J are the axes at right angle to each other. Okay, so they are referring to the 2 different axes. Okay, 2 different axes. Okay, I and J. Okay, then last one is a column matrix. We can using a column matrix to represent the vector as well. Okay, so this is another way we write it. Okay, so this is a notation. Okay. Okay, so for the rest, we have parallelogram addition of the vector. So I think this one I will just continue it tomorrow. Okay, so because once I explain, then I think I should go further. Okay, there may not be enough time. Okay, then I will stop it here just for the introduction. Okay, the definition of the vector, which is they consist of the magnitude and also the direction. So just now we have an example velocity. Okay, so velocity with the magnitude and also with the angle. Okay, then the notations of the vector. Okay, but here is regarding the resultants of the vectors and the addition of the vectors using different methods. So this one I will continue it tomorrow. Okay. Okay, so I think that's all for today. So today I finished slightly early. Okay, so the rest I will just continue it tomorrow. Okay, so is that okay? Okay. Okay, then I will dismiss the class. I will see you again tomorrow.
Okay, bye-bye, ma'am. Thank you.
Okay, bye. See you tomorrow.
Thank you, ma'am. See you tomorrow.
Yep, see you. Bye-bye.
Thank you, miss.
Yeah, welcome.